Greetings everyone. Today we're going to explore the product and quotient rule. To start the lesson, you want to glue in the latest unit divider. You'll also need the exponents foldable. You'll want to be sticking that into your notebook. And then towards the end, you'll want some scratch paper or a marker board to work on some practice problems. First, take a look at your foldable. This is what you want it to look like. So you're going to cut off the top piece that says cut here. And then each section you can cut along the dotted line so that you should have 8 individual flaps. Today, we're going to go through the first 3 flaps on the left side. If you need a second to finish cutting and preparing this, please pause the video if needed. All right, let's turn to the Basics tab in the top left corner. The first thing we need to remember and label is that the larger or main value is called the base, and the smaller raised value is called the exponent. Nothing new, you've learned this in the past, but just know we're going to use that vocabulary, so we have to understand what it means. Let's open that first flap. Inside it says x to the 4th means multiply x by itself 4 times. So there's the definition or the rule. So just to the right of that, we want to write out that rule. So we would say that x to the 4th equals x times itself 4 times. This goes along with the preview video that I wanted you to watch before this lesson. So just very quickly, you don't need to write this down. So let's explore what this expression means. If I was to expand it, that would mean I have 5 times itself. I would have a times itself. And I would have b times itself 3 times. So let's take a look here. If I have the same base, meaning if I have 5 times itself 3 times, oops, and then times 5 times itself 4 times, what does that mean? Well, let's take a look. That means I have 1, 2, 3, 4, 5, 6, 7 5s. So where did that 7 come from? I can expand it to find out, but if I start giving you large exponents, you're not going to want to do that every time. So we have to take a look at the exponents. How can I get from 3 to 4 and get to 7? That's right, we would have to add them. So this becomes the basis of our product rule. In your notes it says, when multiplying things with the same base, you add the exponents. So let's draw an exponent down, or excuse me, an example of these exponents off to the right. If I have x squared times x cubed, if I forget the rule, I could write it out twice and then 3 times, and then count to see that that gives me x to the 5th. Okay, but again, if I have large exponents, that's going to become pretty cumbersome. So if we can remember the rule to add the exponents, that would be very helpful. Under that definition, let's come up with an algebraic rule. A way to generalize this could be saying a to the m times a to the n equals a to the m plus n. So it's another way to see that definition. All right, let's explore another example that you don't have to write down. If I was to expand this example, I would have 2 5s on top and 3 a's on top. And I would have 3 5s on bottom, and 2 A's on bottom. What's anything divided by itself? Like if I have 4 divided by 4, that would be 1. So we typically cross that off because 1 times anything doesn't change it. So in this case, if I cross off, that would be 1, that would be 1, that would be 1, and that would be 1. Let's look at what I have left over. I would have an A on top and a 5 on bottom. Again, you're welcome to expand and do this process. That can get a little bit cumbersome. Let's try one more and see what happens. In this case, I would have 4 2's on top. I would have 4 X's on top. I would have 5 Y's on top. See how long this can get? I would have 3 2's on bottom. I would have 5 X's on bottom. And I would have 2 Y's on bottom. So if I go to cross off, I can cross off. This would be 1, 1, 1, 1, 1, 1, 1, 1, 1. So let's see what I have left over. I have a 2 left over on top. I have 3 Y's left on top. And I have 1 X left on bottom. You can put 1 as an exponent, but you don't need to. So let's see how that happened. I kept the base of 2, but now it has an exponent of 1. How can 4 and 3 become 1? If I subtract them. If I take a look at the x's became an exponent of 1. If I take 5 and I minus 4, I end up with 1, and you keep it where the larger exponent is. And we'll talk a little bit more about why later. And the last value, our y's, we had y cubed left over. Look at those y's. 5 minus 2 leaves me with 3. So the rule is, for the quotient rule, you subtract the exponents. So let's open that tab on our notes sheet. The rule states that when dividing things with the same base, you subtract the exponents. So a generic way to write this rule could be that a to the b power over a to the c power equals a to the b minus c power. Now notice you have to have the same base, so please underline that or make it stick out. If they don't have the same base, you can't combine them in this way. So off to the right where you have some open space, let's fill in an example. I have x cubed divided by x squared. That means I'm going to take the exponents 3 minus 2, which gets me to 1. So my answer is x to the first. 3 is larger, so my first power would stay in the numerator. Those are the only 2 rules we're going to work on today. So at this point, I would like you to get your marker board out, or if you have some scratch paper, or if you'd like to just leave these in your notebooks, you can do that. Make sure you pause and work when necessary, and use your notes as a reference. Let's start by multiplying this one. I'll give you a second to write it down. All right, when we take a look, there's parentheses here. What do parentheses mean in this case? They mean multiplying. So really, I don't even need them. So what I'm looking for is I need to multiply items that can be multiplied. So in this case, let's try together. I'm going to take 2 times negative 3. I'm going to take x squared times x cubed, and I'm going to take y times y to the 4th. Now you don't have to write this out every time, but I just wanted to show you what your thoughts should be. So to start, 2 times negative 3 brings me to a negative 6. An x squared times x cubed means I add the exponents. And y times y to the fourth means I add the exponents. So this is what I need to see as a final answer on a problem like this. All right, please pause the video at this time to write this problem down and solve it, and then we will check back with the answer. All right, so for our answer, we need to multiply the 3 times the 4. We only have one x value, so we keep it as is. And we multiply the y's and add their exponents. All right, please pause the video and work on simplifying this expression. All right, now the only thing I changed here is I used multiplication signs instead of parentheses. That doesn't change anything. I'm going to start by taking the 3 times the negative 4 times the 2. Positive times positive is a negative. And I'm going to look at this as 3 times 4 is 12, and 12 doubled. If I take a look at my x values, I have x to the 4th times x to the 4th times x. If I add those together, I have x to the 9th. And I have a single y value, so I carry that down. So this should have been your final simplification. Please pause the video to simplify this expression. All right, these are conveniently grouped together. So if I combine those exponents by adding, and if I combine these exponents by adding, don't forget that if it doesn't have an exponent, it technically has a 1. Please pause the video to simplify this expression. I'm going to start by taking 5 times 2 to get myself to 10. And then I'm going to take x to the 10th times x to the 4th, which gets me x to the 14th for my final answer. Please pause the video again. A negative times a positive is a negative. 6 times 24. And k to the negative 3rd to the 4th. Okay, so this one should have taken you a little more time. I have k to the negative 3rd times k to the 4th. I add those exponents. So even though it's a negative, I can still deal with it. And I would end up with a 1 for an exponent. So this is actually my final answer. All right, let's work on some quotient rule examples. Please pause the video again. Now, for this example, a couple of things might happen, and we'll kind of work out the details of this a little later. But if I take a look, I know I need to subtract the exponents. Now, my generic rule that I mentioned is keep the x where it's bigger, and 9 minus 5 gets me to 4. So what's left up top? I have to have something, so we can put a 1. Now, some of you might have taken the 5 minus the 9. That would have gotten me to an x to the negative 4th with nothing or a 1 on bottom. This is where we have to work on that rule later. Okay, so for now, my suggestion is keep the value where the exponent is larger. Please pause the video and try this one quick. This one's pretty straightforward, right? So I've got a common base of a, and if I take 9 minus 3, I get 6. No denominators remaining. Again, if you forget this rule on a test, you could just quickly jot this out. 9a's on top, 3 on bottom, cross, 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 and you're left with 6a's. So if you get stuck, try that. Please pause the video to try this one. Alrighty, let's take care of the coefficients out front. 18 divided by 6 is a positive 3. The 7 is larger, so my x is going to stay on top. And 7 minus the 3 gets me to 4. So I no longer need that division bar. All right, please pause the video and try this one. All right, this one looks a little different because my base is a negative 3, but that shouldn't change anything to get going. Keep the common base, subtract the exponents, the larger ones on top, so it's going to stay on top. Now, let's actually work together to take this a step further. This is a number to a small exponent. I can solve that. This means negative 3 times negative 3 times negative 3 times negative 3. Even number of negative signs being multiplied will always become a positive number. 3 times 3 is 9, times 3 is 27, times 3 gets me to 81. So if I simplify this all the way down, it would be 81. Now, I still want to see this on your work. I want to know that you understand the property before you calculate. Because some of you could plug that in your calculator, and I'm not going to know if you understand the rule. So I need to see that first. Please pause the video and try this one. All right, the first thing I'm going to deal with is the constants, or the coefficients out front, 8 is not divisible by 6, but it does reduce. We always reduce fractions. If I take a look at my x values, the larger one's on top. 3 minus 1 is 2. I look at my y values, the larger one's on bottom. 3 minus 1 is 2. So this would be my final answer. All right, please pause the video again. All right, let's deal with the coefficients first. 15 is divisible by 3. It is 5. The larger b exponent is on top. 3 divided by 2 is 1. So I don't even need to write anything. The larger c exponent's on bottom. 5 minus 2 is 3. So 5b over c cubed is my final answer. Please pause and try this one quick. All right, so here I have 21 divided by 3, which works out nice and neat as a 7. The larger y values on bottom. 5 minus 3 is 2. Please pause and try this one. All right, I have my coefficients out front. A negative divided by a positive is a negative, and 12 divided by 4 is 3. Let's deal with the a values. The larger a is on top. 10 minus 7 is 3. The larger b values on bottom. 4 minus 3 is 1. So that would be my final answer. All right, your task to finish out this lesson is you do have a worksheet that'll be provided to you, or check out Google Classroom. Make sure that you finish this before next class. I'll come back, and if you're watching this due to an absence or due to me being gone, I will check your notes when I get back as well. So until next time, have a good one.